Perfect. Okay, so hello again. Wajeeha Hamid, product manager in Canonical and OSM Marcom chair. So together with me is David Garcia, who is leading multiple efforts in community and VC module and Charmed OSM activities. Next slide, please. Yeah, so starting with our contributions in the community, we are very dedicated to OSM and currently leading these positions. That is, we have Mark Shuttleworth, CEO of Canonical, as a senior advisor for OSM community. We have TSC membership, and Mark Barrel is a part of TSC. Then we have module development leads for RO and N2VC modules. That is David Garcia and Eduardo. And finally, the task force positions are led by Canonical Team 2, Matcher for VNF voting and myself for Marcom. So we are happy to be a part of it and trying to make OSM a successful project in open source community.
Okay, so today, before doing the actual session about debugging OSM, I'm going to explain very basic concepts for everyone to understand. So Juju is part of the OSM core, and for all of you that don't have the knowledge about what Juju and Charms are, let me briefly introduce them. Juju is a model-driven operator lifecycle manager that is able to deploy operators to different cloud substrates like LXD, OpenStack, Kubernetes, and public clouds such as EKS, AWS, GKE, and so on. These operators are called charms, which are Python-based operators that handle the life cycle of an application. For example, the slide shows a Grafana operator, which is a Python code that includes all the scripts for installing, configuring, upgrading, and so on, the Grafana application. Additionally, they allow us to execute day 2 operations. In this example, this could be an example of an action, get admin password, just so an action that will retrieve or will return the admin password for Grafana. And it also allows the integration between different operators. So now that we understand the very basics of Juju and Charms and the benefits, I will show how this is useful inside OSM. OSM is able to manage different types of network functions, virtual, physical, and containerized. As I mentioned before, Juju is part of the OSM core, and this means that for each network function, it can deploy a charm in order to automate and handle the life cycle of the workload. And not only that, this charm could have also custom actions to the particular or that are particular to the specific network functions, like, for instance, doing a backup, restore, add a user, or whatever. There are no limits of what can be done here. It's just Python code that is specific to a workload. And also, it has some mechanisms to integrate with other network functions that are called relations. And well, basically, they allow multiple network functions to work together and integrate between each other. So in summary, charms include the scripts that automate all these kind of operations.
Okay, so what is actually Charmed OSM? It is an effort led by Canonical to provide an OSM with the same concepts that are explained by David. That is, we have converted all the modules of OSM into operators or charms and implemented the same day two concepts to the installation and management of OSM itself. Like just like OSM uses Juju for the workloads configuration, we can use Juju for the installation and configurations of OSM itself. And that's what we have done with Charmed OSM, making OSM a model-driven deployment. For the day two operations, you can scale up and down these modules or charms individually whenever you want, whatever you want. So overall, like Charmed OSM deployed with Juju fully automates the installation process, and it really simplifies ongoing OSM operations. Next slide. Yeah. So if we want to choose Charmed OSM, then what are the benefits we can get? First of all, it is fully open source, and it's in all the code of Charmed OSM is upstream, and Canonical, as a contributor of Ubuntu, we always stand for open source, as this is the best way to get contributions from around the globe, and that's what we wanted from OSM also. Then it is career grade. By that, we mean that it has the ability to respond to enterprise needs like high availability, geo-redundancy, security from infrastructure to the apps. Then we have a full enterprise support for OSM. Like if you face any bugs and need support, our experts who are actually in a part of OSM are there to help you with the bug fixes and any type of security updates needing in your solutions. And at the end, we really wanted to work with community partners and telcos to ensure that Charmed OSM will be a perfect fit for all telco use cases and actually help drive the business effectively for most of the telcos. Next slide.
Okay, so in this session, I will be presenting debug mode in Charmed OSM, which is a feature that comes along with the release, the OSM release 11. And basically what it is, so debug mode is just an option in the OSM charms to enable the debugging of these modules. It can be enabled in MVI, RO, LCN, MON, and POL. And the main objective of this feature is to provide the OSM community with a mechanism to debug OSM, allowing them to extract deeper analysis, minimizing the spend time as much as possible when debugging and testing patches. We consider this a very important thing because there are production deployments of OSM at the moment, and this will and is requiring bug fixes to be made in a timely manner. So the benefits of this it's clear. And another benefit of the Charmed OSM debugging mode is that it is really simple to set up, and the setup is really minimal, so there are no a lot of things that you need to prepare in order to start debugging OSM. So that helps not wasting too much time, and you can actually spend more time in what is more important. So this is how the debug mode is enabled in the different OSM modules. The good thing is that it's really simple, and also it's unified across modules. All the modules can use the debug mode in the same way. Also, the debugging happens over SSH. So you can debug OSM running in your local machine or in a remote one. It doesn't matter. So it gives you some flexibility there. A really convenient thing also is that when the debugging mode is enabled, a VS Code workspace is generated and added to the workload container that you are debugging. This means that when you will start debugging, the VS Code workspace will automatically show the folders that are interested for you. So, for example, if you are developing or debugging, sorry, LCM, LCM depends not only in the LCM source code, but also in the common source code and N2VC. So all those three folders will appear in the workspace automatically, so you can start right away with the debugging. Additionally, no more Docker build will be needed. The container images that are used for debugging are the same ones published by Jenkins. So not having to build custom images for debugging reduces drastically the time needed to debug. And also it's useful because we make sure that the testing environment is identical to the production environment. So the final images that are going to be used are exactly the same ones as the ones that we are using in the testing. So let's explain how this works. In the right, we have OSM and we have all the Charmed modules that Juju deployed in an OSM model. Okay, let's focus on only one component, NVI. In order to enable the debug mode in NVI, we just need to do Juju config NVI debug mode true. And it will ask us for a debugging public key, SSH public key. So we introduce that by using that command, okay? And this is needed because the debugging happens over SSH, as I mentioned before. So that key will be injected to the NVI container so that the SSH can happen securely. Okay, let's focus now on NVI only. So when the debugging mode is enabled, the NVI container will be restarted, and two things mainly will happen. One is that SSH will be enabled, and the other thing is that the workspace I mentioned before will be added to the container. So in this case, or at this point, we are ready to go and ready to debug it. So next thing is the demo. Let me open VS Code, and let me know if you can see properly or if I should make it a bit bigger. Well,
I think
I'll
it's
assume
okay.
that it's
It looks okay for me. Anyone else?
Yeah, it looks
Okay.
fine to me too.
Okay, perfect. So this is a VS Code. It's just the terminal, okay? And I already enabled the debug mode in NVI, okay? Because well, it needs to restart the pod and so on. So I did it before, just a couple of minutes before, not to lose too much time. So this shows the status of our OSM deployment. We have all the charms here and the deployment of Charmed OSM from release 11 branch. So in order to enable the debug mode, what I did is I executed this line enabling the two configs, or setting the two configs that I mentioned before, the debug mode to true and then the public key. If you see the Juju status after that, you will see that a new NVI unit was spin up, and with the 22 port SSH port enabled for SSH access. So this new container or pod was is ready to be debugged. So after that, it finished and well, basically the container is ready at that point. Another thing that we added into the DevOps repository is a script to generate an SSH config file that will, let's say, automate the generation of the SSH host in the config file so that it automatically appears in the remote explorer in VS Code. So executing the generate SSH config script will detect which modules have the debug mode enabled, will generate the config, and the NVI, in this case, will appear as a target in the SSH targets of the remote explorer. So what we need to do is right-click and connect to host in a new window. Okay, what this does is it shows a new window, and we are connected to the SSH or to the NVI pod, and it's this connection is done through SSH, as I mentioned already a couple of times. And okay, so once we are here, the only thing that we need to do is open a workspace from file. And as I said before, a workspace is already mounted to the container that is called debug.code workspace. So if we click there, it will open the workspace for us. And as you see, the three main components of OSM that are used in NVI are here: OSM NVI, OSM Common, and NVI. Additionally, this container or the workspace has the launch scripts already prepared, so that the only thing that we need to do to actually run NVI is go to Run and Debug and click the play button here. But before I do that, let me go to the nvi.py file, okay, and let's add a breakpoint here so that when we run it, we see that we can actually debug NVI. So we click the play button, and well, it's running NVI, and it's just stopped here, so we can go step by step and see the variables here. Well, this is common debugging. Let's click continue, and well, NVI will start at this point. An interesting thing is that NVI will be still running in the Kubernetes cluster. So that's really convenient, because it will run, or it will be running in the same environment as in production, not in a separate Docker file or in a local machine or anything. It will be running and be tested in the same Kubernetes cluster, which is really convenient. Okay, so there's only one thing left that I will explain with the next slide. As I showed in the demo, NVI is running in Kubernetes, and the changes that we may do to the source code of NVI, for example, will be persisted in the container. So this is a problem that we have a solution for. And the thing is that we want to persist the changes that we do in some occasions, at least. We want to persist them in our local machine, not in the container, because if the container restarts, we will lose all the changes, which we don't want that to happen. So normally in the same node as the Kubernetes is running, for example, if we are running OSM in our laptop, we should or we may have a folder with the NVI source code. So there's a config that is debug NVI local path, that basically what we do is we put there the path to the local path to the NVI repository that we have. And what this will do is this will mount that local folder to the NVI pod, which is really convenient because all the changes that we will do in the container will be persisted locally. So that when we are done doing the patch, we just go to our local machine, do the commit, and we contribute it directly to upstream, saving some time there. Okay. I finished the presentation, but let me jump here. Okay, and let me show this. Okay, I already set up the local path for NVI. So let me do this. Okay, so the value for the debug NVI local path is this one. Okay, and if I do an ls of that, I see well, the source code of NVI. So let's do one thing. Let's go and do a cut of some file here. For example, nvi.py, and let's show just the first 5 lines. Okay, now I will go to the container itself and put here something like this is a change, save it, and this change is happening in the container. So if I go here, which is my local machine, I see that the change is persistent. Okay, so that's all from my side. Any questions?
Thank you, David. I guess there were a few questions in the chat, which is already answered by Mark. Do we have any other questions?